Alright, so we're going to have to follow the product rule. 1d2 plus 2d1 plus 1d2 plus 2d1 equals 0. And now we divide everything by dx. And we want to get the dy's together. So I have x squared, takes care of that one, plus 2xy, takes care of that one, and then all these other ones have to go to the other side. Minus y squared minus 2xy. Now I'm going to solve for dy over dx, which is minus y squared, divide by this other factor, and I am now done. In this example, they want us to find the derivative by implicit differentiation at this point. So we're going to have to use differentials again. 2x dx minus 3y squared dy equals 0. Divide everything by dx. And we're going to say that dy dx is going to equal 2x divided by 3y squared. And they want us to check it at the point 1, 1. So I'm going to actually put in 2 times 1, 3 over 1 squared, and I get 2/3. And I am finished. In example 34, they are asking us to find the explicit functions, which means I need to solve for y. So 4y squared equals 4 plus x squared, and I'm going to divide by 4, and then I'm going to take square roots, which means plus or minus. There is my equation. Those are my two explicit functions. Now they want us to sketch the graph and label the parts. So basically we have a, it's probably going to be very similar to, well, let's look and see what it looks like. So we could simplify this. We could say plus or minus 1/2 4 plus x squared. Looking up here, I can tell it's a hyperbola. It's a y squared, so it does look something like this. Now, what I need to know is which one is the explicit one. The positive one is here, the negative one is here. So, this would be the 1/2 4 plus x squared. This one would be the negative 1/2 4 plus x squared. So that's what we have for those explicit ones. Now they're asking us to differentiate it explicitly, which means I now have to take derivatives. So if I think about it, I'm going to rewrite it as 1/2 4 plus x squared to the 1/2. Taking a derivative of the positive one, I get 1/2 times 1/2 4 plus x squared to the negative 1/2 and times the derivative of what's inside. So now what I have is that my first derivative is going to be x over 2 4 plus x squared to the negative 1/2. Now the same thing's going to happen with the other one, so I'm going to put plus or minus. And those are my derivatives for using the explicit one. It doesn't make it very easy, but let's see if we can do some simplification. Looking at this, we got an issue because we've got that silly square root. So what I'm going to do is I'm going to write x over 2, and I'm going to write it 4 plus x squared. Now, to get rid of the radical, I have to multiply top and bottom by 4 plus x squared. So far, so good? Now, what I end up having is 4 square root of 4 plus x squared on top, and I end up with 2 times 4 plus x squared on the bottom. Well, what does 4 plus x squared equal? It equals y squared. So I'm going to say 4 square root of 4 plus x squared all over 2. And this particular part here is equal to 4y squared. So the 4's cancel, and that's what I end up with. Here's the derivative in number 34. Let's see if we can do some simplifying, because it sure does look pretty ugly. What I have down here is 4 plus x squared. And if I remember my original equation, it looks like this. So if I rearrange it, 4y squared equals 4 plus x squared. Doesn't that look like what I could put in here? So I have plus or minus x over 2. This particular part happens to be the square root of 4y squared plus or minus x over 2 times y. And so I end up with plus or minus x over 4y. Never would have thought of simplifying it like that, but that's the explicit way. It is a lot of work to take it and make it look like this. The next part of 34 says, in part D, let's just solve this implicitly and see why implicit differentiation is sometimes easier. Well, I'm going to say 8y dy minus 2x dx equals 0. Divide everything by dx, and now I'm going to solve for dy over dx, and I get 2x over 8y, which is dy over dx equals x over 4y. Ta-da! And it does it all explicitly, or implicitly, and takes number less. Number 36. It tells us to find the second derivative in terms of x and y. The easiest way to do this, because remember we're doing it implicitly. So what we're going to do is write it out like this, and now we're going to take the derivatives. This is a product rule. So 1 d2 plus 2 d1 minus 2 dx equals 0. All right, so what we're going to do is we're going to have to find the second derivative. So we're going to go 2y, and it's explicit, so we're going to say y prime equals 4, and that's with respect to x. And now I'm going to solve for y prime, which is 4 over 2y, which is 2 over y. Now I need to take the second derivative. And so what I'm going to do is I'm going to actually write it as 2y to the negative 1. The second derivative says I'm going to bring down the 2, take it to the negative 1, and then we're going to say y to the negative 2, and then we did y prime, because we did it with respect to y. So now what I have is negative 2 over y squared, and this is a y prime. Make sure it looks like a y prime. Well, what does y prime happen to equal? Y prime happens to equal 2 over y. So now I end up with a negative 4 over y cubed. All right, in this problem, number 42, we need to find the equations for the tangent line and the normal line to this circle at this point, and then that's about it. So what I need to do is take differentials. So 2x dx plus 2y dy equals 0. 2y dy over dx equals negative 2x. dy dx equals negative x over y. So that is the slope of my tangent line. So what I'm going to do is I'm going to find the slope plugging in 0 over 3. And then I'm going to find the slope plugging in negative 2 over the square root of 5. So now what I have is here's the slope at this point, and here's the slope at this point. And they want us to find the equation of tangent lines. Well, this is a horizontal slope, so it's going to be the equation for at x equals 0, the tangent equation is y equals 3. So there's the tangent equation. Now it is a horizontal, so the perpendicular line is a vertical line. So the normal line should be x equals 0 because it goes through that point. All right, so now let's look at the point 2 square root of 5. Now my tangent line has a slope of negative 2 square root of 5. So what I'm going to do is take y minus, this is my tangent line, y minus the y value equals negative 2/5 square root of 5 x minus 2. So y equals negative 2 square root of 5 over 5 x minus 2 plus the square root of 5. There's the equation of my tangent line. To find the normal line, I'm going to take the opposite reciprocal, and I'm going to use the same point. So y minus the square root of 5, opposite reciprocal, and x minus 2. So now I'm going to put in 5 over 2 square root of 5 x minus 2 plus the square root of 5. And let's see what we end up with. Now, if I get rid of the radical down here, I'm going to end up with 5 square root of 5 over 5, so y equals square root of 5 over 2. And I'm going to say this is now my normal line. You could do some more simplifying, but that's good enough.